Students, welcome back. In our previous session, we have started with a topic called as simplex method. Then we have understood all the basic concepts about transforming a given LPP problem into a standard form. Now we'll go ahead and try and understand how to tackle a particular question on simplex method. Now students, remember there will be two different kinds of questions that you might encounter while solving problems. In the first type of questions, you will have the subjective functions as equalities. Very important. In the first type of questions, you will have the subjective functions as equalities. Whenever equalities are present, then we do not proceed with something called as a simplex table. Now what a simplex table is, let us not worry about it at this moment, because in this type of question we are not going to make use of simplex table. Simplex table we will learn when we start with subjective functions where there will be inequalities, less than type or greater than type. So at this moment, let's not worry about simplex table. So the two kinds of questions that we'll be encountering, in the first type of questions, you will have subjective functions with an equal to sign. So I've written one question here: maximize z equal to 2x1 minus 2x2 plus 4x3 minus 5x4, that is minus 5x4, that is my objective function. Subjective functions are, there are two subjective functions, and the two subjective functions have an equal to sign. So this is very important. There are two kinds of questions. One type of problems where the question will have an equal to sign, and the other type of question where you will have an inequality sign. Whenever an inequality sign comes, we will make use of something called as a simplex table, and when an equality sign comes, we are not going to make use of simplex table. So at this moment, let's not worry about what that simplex table means. So let's begin with the question. Let's understand how to tackle this kind of question when you have the subjective functions with an equal to sign. Now students, what we are trying to do here, we are trying to find the solution. So again, there are some terminologies that will be involved to understand this question. So we have to understand the terminologies first very properly, and then we can proceed with the solution. So what I'm trying to do here is I'm trying to find the solution of this equation, of this particular LPP problem. What do I mean by solution? Solution is nothing but those values of the decision variables which will satisfy the equations. Listen to the statement very carefully. I said solution is the values of the decision variables. So who are the decision variables in this particular problem? The decision variables are x1, x2, x3 and x4. So there are four decision variables. Now these decision variables, if I solve the equations and I get some values, that values will be called as the solution. Getting? Now once I understand what a solution is, the next point that I want to understand is what a feasible solution is. So solution, then next comes the feasible solution. Feasible solution will be those values of the decision variables, which satisfy the two subjective functions, as well as it satisfies the non-negativity constraints also. Remember, when we solve the equations, it might be possible that the values of x1, x2, x3 or x4, they might come negative, isn't it? That is quite possible. The values of x1, x2, x3, x4, they might come negative also. So whenever they come negative, it means that the equations have a solution, but it is not a feasible solution, because the non-negativity constraint also has to be satisfied. The non-negativity constraint, that means the variables x1, x2, x3, x4 has to be greater than or equal to 0. When particular values of decision variables, when they satisfy the subjective function as well as the non-negativity constraints, then and only then they will be called as the feasible solution. So there was a solution will satisfy only the subjective functions. Then there is a feasible solution. A feasible solution will satisfy the subjective functions as well as the non-negativity constants. That's called a feasible solution. Once you get the feasible solution, there can be multiple feasible solutions, students. Once you get feasible solutions, those values which when put up in this objective function gives us a maximum or a minimum value depending on what question has been asked. That particular solution, that particular feasible solution will be called as an optimal solution. So there is solution which satisfies the subjective functions. There is what you say here. So there was first of all a there is a solution. So there is a solution which will satisfy the subjective functions. Then there is a feasible solution which satisfies the subjective function as well as the non-negativity constants. And then there is an optimal solution. So a feasible solution can become an optimal solution when it will give either a maximum or a minimum value of the objective function. A feasible solution which gives a maximum or a minimum value of the objective function is called as a optimal solution. So solution, feasible solution and optimal solution. Now I want to get the optimal solution here. Now have you observed, if I want the values of x1, x2, x3 and x4, I have to solve the equation simultaneously. But the problem is I have only two equations, isn't it? I have only two equations, and the rule of mathematics tells me that two equations can give us only two variables. It can give us the values of only two variables, but we have four variables. That means there is no chance I will be able to get all the values, all the four variables by solving the two equations only. So here comes the next concept. Now there will be something called as a basic variable and a non-basic variable. A basic variable and a non-basic variable. What is the difference between the two? Let's try and understand that. If you observe these equations, there are two constraints. These are called constraints. The subjective functions are also called as constraints. So there are two constraints at this moment given to me. So number of constraints, I'm going to call it as M. So M is the number of constraints. Okay. Then how many variables are involved in the given LPP? There are four variables involved. So there is no slack and a surplus variable because the question is of equality type. So whenever you have an equality type of subjective function, then there is no point in discussing a slack and a surplus variable. So at this moment, if I take all the decision variables, all the slack, all the surplus variables, still I'll be getting four number of variables. So N stands for the number of variables. Okay, so these are the two terminologies that you want to understand, and why we are understanding this, again make a note of it. We have two subjective functions, but we have four variables. Now two equations cannot give me the answers of four variables, hence now the idea of basic and non-basic variables has kicked in. So we need to understand what is a basic and a non-basic variable. To understand that, first of all, what I have done is I have taken number of constants as M and number of variables as N. Now if I do N minus M, that will give me something called as a non-basic variable, number of non-basic variable. So I'm going to write here number of non-basic variable. So has this question popped up in your mind? What's a non-basic variable first of all? So students, wait for a moment. I'm going to tell you in a fraction of a second what is a non-basic variable. So first of all, the number of non-basic variables, I'm going to get it by doing N minus M. So how many number of variables I had here? There are four number of variables. So I do 4 minus how many constants? There are two constants, so I get 2. So there are two non-basic variables. These are those variables whose value I am going to assume as 0. So non-basic variables are those variables whose value I'm going to assume as 0. So non-basic variables are those variables whose value should be taken as 0, because you can observe there are only 2 equations and 4 variables. So 2 equations cannot solve 4 variables. That is why I'm going to assume some variables as 0, but which variables should be taken as 0, which should not be taken as 0, that also we'll discuss in a short while from now. But before that, the values which I'm going to assume as 0 are called as non-basic variables. The variables for which I'm going to take the value as 0 will be called as non-basic variables. Now, how many non-basic variables I want to select, that will be given by formula n minus m. What was n? Number of variables. What was m? Number of constants. So here I'm going to assume 2 variables out of the 4 variables equal to 0. Now, which 2 variables should be taken as 0? So see what order I usually maintain. So I now know that I need to take 2 variables as 0. So I take the order like this. I take x1, x2 as 0. Then I take x1 and x3 as 0. Then I take x1 and x4 as 0. So did you observe x1 was kept intact and I kept changing x2, x3 and x4. So these are the 3 non-basic variables. These are the 3 non-basic variables set, I can say, that I'm going to take as 0. Now once x1 is completely done with, I take x2. Now x2 and x1 there is no need to take, isn't it? Because x1, x2 is already taken. So x2 and then you take x3. x2, x3, x2, x4. Did you observe this also? So I have taken x1 and then I have taken x1, x2, x1, x3, x1, x4. So keep the first variable intact and take all remaining variables. Then you can take the next variable as x2, isn't it? And take the other remaining variables. x2, don't go back. x2, x1 is no need to take because x1, x2 is already taken. So x2 and go ahead. x2, x3, x2, x4. Then you go to the next variable. So x1 is done, x2 is done. Next variable will be x3. So x3 becomes my next variable. So x3, again don't go back. x3, x2, no need to take, already taken. x3, x1, no need to take, it is also already taken. So go ahead, x3 and x4. x3 and x4. So these are called as the non-basic variables. Did you get that? These are called the non-basic variables, and these variables I'm going to take the value as 0. I'm going to assume their value as 0. Now once I have decided who are my non-basic variables, the remaining variables will be called as basic variables, and those are those variables whose value I am going to get by solving the 2 equations. Now why I say 2 equations? Because there are only 2 constraints given to me. So these 2 constraints can give me 2 variables, and the 2 variables I have taken them as 0. So this entire story has to be put up in very properly in proper places. So first of all, you need to understand how to get the number of non-basic variables. Who are the non-basic variables? The variables whose value I'm going to take as 0. Then n is number of variables, m was number of constants, isn't it? So I've made some pairs x1, x2, x1, x3, x1, x4. Then take x2, x2, x3, x2, x4. Then take x3, x3 and x4 and so on. Now the remaining variables will be called as the basic variable. So here x3 and x4 becomes the basic variable. Here x2 and x4 becomes the basic variable. Next is x2 and x3 becomes the basic variable. Next is x1 and x4 becomes the basic variable. Next is going to be x1, x3, and finally x1, x2. So here also you can observe, keep x1 fixed. So x1, x2, x1, x3, x1, x4, isn't it? Then take x2, x2, x3, x2, x4, and then x3, x4. So these set of variables will be called as basic variables. These are those variables whose value I am going to get by solving the 2 equations simultaneously. So there is non-basic variable and then there is basic variable. I hope you have understood so far, isn't it? Now let's move ahead to get the solutions of this. So solution was there, then there was feasible solution, then there was optimal solution. Then I need to solve the 2 equations simultaneously. That was not possible because I have 2 equations and I have 4 variables. So I need to take something called as non-basic variables. Non-basic variables, those variables whose value is going to come 0. I'm going to take them as 0. Basic variables whose value I'm going to find now. So I'm going to construct one table here. So I can observe here that you have understood what is the concept of a non-basic variable and a basic variable. So I'm going to erase this part from here. Let's keep this part intact over here so that to understand how I got to get the values of non-basic variables. So I'm going to remove this part and I'm going to make a table over here. So let's remove these basic and non-basic variables and we will construct one table here. So one very important point to be noted here is, did you observe I've got 6 values. Now how do I come to that result of 6 values? That is also very important. I can say number of solutions. I'll write here number of, I should better say basic solutions. The number of basic solutions is given by the formula NCM. It is NCM. So N was nothing but what? The number of variables. M was number of constants. So I had 4 variables and 2 constants. So 4C2. If I solve this, I get 4 factorial upon 2 factorial, 4 minus 2 again 2 factorial. So that's 4 into 3 into 2 factorial, again 2 into 1 and again 2 factorial. This cancels, 2 and this cancels. Answer is 6. That means there should be 6 basic solutions. And do you observe this 6 basic solutions? How were they given? The 6 basic solutions, how were they given? So it was, how I have taken it? I have taken x1 as fixed one, and then x1, x2, x1, x3, x1, x4, isn't it? 3 of them. Then you take x2 as fixed one, don't go back, go ahead, x2, x3, x2, x4, isn't it? 2 more, and then again go the next one, the next variable was x3. Again we don't have to go back, so x3, x4 is going to be the last one. If you count them, there are 6 number of basic solutions. So these were the non-basic variables. The entire solution will be called as a basic solution. So again basic solution is going to be of 2 different types. So basic solution will be of 2 types. One will be called as a basic feasible solution and one will be called as basic infeasible solution. We will come to this discussion also in a short while from now. Just wait for a moment. So I'm going to take these 6 set of values. I'm going to construct one table here. So now I know there are going to be 6 feasible solutions, isn't it? So first of all, I'll write the non-basic variables. First of all, I'll write the non-basic variables. The non-basic variables. So do you remember in the non-basic variables how the pairing was done? I have taken x1 and x2, then x1 and x3, then x1 and x4, isn't it? Then x2 and x3, x2 and x4, and finally x3 and x4. So if you count 1, 2, 3, 4, 5 and 6, there are 6 solutions. 6 basic solutions are going to come. So the entire table is going to be called as a basic solution. So 1, 2, 3, 4, 5 and 6. And these values are going to be taken as 0. All these values I'm going to take it as 0. So initially I have taken x1, x2 as 0. Then x1, x3 has been taken 0 and so on and so forth. Understood? So that's non-basic variable. Sorry. The next one will be the basic variables. Basic variables. So once I have identified that x1 and x2 are my non-basic variables, the basic variables become x3 and x4, isn't it? Basic variables become x3 and x4. Then here non-basic variables was x1 and x3. So the basic variables are going to become x2 and x4. The next one is x1, x4. Next one is x1, x4. So I get here x2 and x3. Then x2 and x3 were my non-basic variables. So I get x1 and x4. Next is x1 and x3, x1 and x2. So that's my next column where I have taken the basic variables. Once I've got to know what are the basic variables, I'm going to write my equations. So I'm going to write the subjective functions, the equations. So let's write the equations and let's simultaneously solve also. So if I take the first equation, I'm going to take x1, x2 as 0. So x3 and x4. x1, x2 are taken as 0. So what's the equation left? Minus of 2x2, minus of 2x3 and plus 8x4. Then 3x3 plus 4x4. It was 2, it was 1. So students, I'm going to solve these two equations simultaneously. So if I solve these two equations simultaneously, so I'll do a rough work. I'll write the values directly here. So from here I'm going to get the value of x3 and I'm going to get the value of x4. So very quickly let us get the values of x3 and x4. So I have minus 2x3 plus 8x4. You multiply this equation with let us say 2. So I get 6x3 multiplies with 2, you get plus 8x4 multiplies with 2, you get 2 on the right hand side. Subtract the two equations, so you get minus of 2x3 and minus of 6x3. That's minus of 8x3. This cancels. 2 minus 2 is 0. That means you have got x3 as 0. So x3 came 0. Take x3 as 0, put in any one of the equations and get the value of x4. So if I put here the second equation, if I put x3 as 0, I will get x4 as 1 upon 4, isn't it? So solving the two equations simultaneously, I have understood that the basic variables has come, x3 has come 0 and x4 has come 1 upon 4. Now these two values of x3 and x4 are satisfying the non-negativity constants, isn't it? They are satisfying the non-negativity constants. That means this particular values can be called as the feasible solution. These values are obviously these values are satisfying the subjective functions, isn't it? These two values have been brought by solving the two equations simultaneously. That means they have to satisfy their original equations as well as they are satisfying the non-negativity constraints. That means, is the solution feasible solution? The answer is yes. So I'm going to write here, is the solution feasible? So my answer is yes, it is a feasible solution because they are satisfying the non-negativity constants. Let's move on to the next equation. So we have the next equations from here. I'm going to get my next equation. So I'm taking x1 and x3 as 0, isn't it? x1, x3 is taken 0, x1 and x3 is taken 0. So I get 4x2 plus 8x4 and 2x2 plus 4x4. This was 2, this was 1. Now did you notice here, if you take the first equation and divide it by 2, you get again 2x2 plus 4x4 is equal to 1, isn't it? This equation will transform into 2x2 plus 4x4 is equal to 1, which is same as the next equation. That means these two equations cannot be solved among themselves. That's not possible, isn't it? The two equations are same equations. So I cannot get two variables from one equation. So such kind of equations will give us something called as an unbounded solution. These two equations cannot be solved. So these two equations cannot be solved. So I'm going to get something called as an unbounded solution. So I will say the solution is not feasible. So I'm going to write here, is the solution feasible? So I'm going to write no here. So that was my second set of values. Let's move to the next set of values, x1 and x4. So now in x1 and x4, if they are taken 0, so my equations will become, so I've taken x1, x4 as 0. x1 and x4 is taken as 0. So I get 4x2 minus of 2x3 equal to 2 and 2x2 plus 3x3 is equal to 1. So I'm going to solve these two equations simultaneously. So while solving these two equations simultaneously, look at the equations again. We have 4x2 minus 2x3 equal to 2 and the other equation is 2x2 plus 3x3 is equal to 1. So again I want to solve them simultaneously. So what I do is I'm going to multiply the second equation by say 2. So I get 4x2 plus 6x3 is equal to 2. So take the first equation, take this next simplified equation, isn't it? I have multiplied the previous equation by 2 and subtract them. So this time you get subtraction, 4x2 minus 4x2, again 0, minus 2x3 and sorry, minus of 6x3 will give me minus of 8x3 and 2 minus 2 again 0. So x3 came 0, isn't it? So x3 is going to come 0 for this particular case. So I write here x3 came 0. If you put x3 as 0, what is x2 going to come? So put x3 as 0 here. You can take the second equation. x3 is taken as 0, so x2 comes 1 upon 2. x2 came 1 upon 2. So this is nothing but again what? Feasible solution, because both the values are satisfying the non-negativity constants. Obviously they will be satisfying the previous equation. So this again I'm going to call that these values of x2 and x3 are giving me a feasible solution. So I'll write yes here. So I hope all these things are so far well understood to everyone, isn't it? So I'll remove this rough work from here. Let's move ahead. In the next set of values, which is x1 and x4, these are my x1 and x4. These are my basic variables. So here I have taken x2 and x3 as 0. So I'm going to take x2 and x3 as 0. So if I take x2 and x3 as 0, so what equations I'll be getting? Let's write the equations. So if I now take x1 and x2, if I take x2 and x3 as 0, so let's take x2 and x3 as 0. So I'm going to get x1 plus 8 x4 is equal to 2, and then x2 and x3 was taken 0 the next one. So I get minus of, this was x1, minus of x1, x2 and x3 is taken as 0, so plus 4x4 is equal to 1. So that's my next set of equations. Let's solve these two equations also simultaneously. So I have x1 plus 8x4 is equal to 2 minus x1 plus 4x4 is equal to 1. I'm going to simply add these two equations. So x1 and x1 gets cancelled. 8x4 plus 4x4, that's 12x4, and 2 plus 1 is 3. So I get x4 as 3 divided by 12, that's 1 by 4. So I've got a value of x4 which is 1 by 4 from here, isn't it? If I take this equation, this value x4 equal to 1 by 4 and put up in the previous equation, put x4 as 1 by 4, 1 by 4, 1 by 4, 4 and 4 cancels, you get 1 here, transfer on the other hand side, 1 minus 1 becomes 0. So x1 is going to come 0. So I can write over here that x1 came 0 and x4 came 1 by 4. Student, this is a simple task. You can also take these equations and solve them on your own to get the values, isn't it? So x1 came 0, x4 came 1 upon 4. Are these values again satisfying the non-negativity constants? Indeed they are. That means these values are also nothing but what? These are also the feasible solution. So I can observe that the first 4 set of values are giving me the feasible solution. But over here I've got an unbounded solution. And why did I get the unbounded solution? Because the two equations came same. Let's move on to the next one, where x2 and x4 are to be taken as 0. So I'm going to write x2 and x4 as 0. So when x2 and x4 become 0, I get x1 minus 2x3 minus of 2x3 is equal to 2, and the second equation is going to be minus of x1 and plus 3x3 is equal to 1. So these are the two equations. Again I want to solve them simultaneously. So I'm going to write it out over here. There is x1 minus of 2x3 equal to 2 minus x1 plus 3x3 is equal to 1. Add the two equations. x1 cancels. 3x3 minus 2x3 is x3. You are adding the two equations, you get 3. That means you have got the value of x3 as 3. You put in any one of the equation. Let us put it in the first equation. So x3 is taken as 3 here. You get minus 2 into 3, that's minus 6. Goes on the other hand side, becomes plus 6. x1 comes 8. So x3 is 3 and x1 came 8. One more set of values, and this set of values also satisfies the non-negativity constraint. Hence I will call this is also a feasible solution. One last set of values is left. x3 and x4 is going to be taken as 0. So when I take x3 and x4 as 0, what equations I'll be getting here? x3 and x4 are taken as 0. So I get x1 plus 4x2, just bear with the last part please, equal to 2, and then minus x1 and then plus 2x2 is equal to, I have 1, Again, I'm going to solve the two equations simultaneously. So if I add them, I get 4x2 plus 2x2, that is 6x2. 2 plus 1 is 3. So 6x2 is equal to 3. x2 comes 1 upon 2. You can select any one of the equations. Suppose I select the second equation. x2 is taken as 1 upon 2. 2 and 2 cancels, you get 1. Transfers on the other hand side, you get 1 minus 1. Becomes 0. So I can from here write x1 came 0 and x2 came 1 upon 2. Students, make sure that you solve it very properly in your notebooks. So x1 and x2 again are satisfying the non-negativity constants. That means here also I can say that I'll be getting a feasible solution. So every single time I'm getting a feasible solution. Now students, it might happen sometimes that some of the value may become negative. That is quite possible. While solving the equations, it would have been possible that some of the values would have become negative. At that time, that particular solution will be called as a basic infeasible solution. So there is a basic feasible solution and a basic infeasible solution. Feasible solution, the solution has to satisfy the two equations. Obviously it will satisfy, and it should satisfy the non-negativity constants also. Then it will be called as a basic feasible solution. And if some of the values came negative, that means they are satisfying the subjective function. They are satisfying the subjective function but not satisfying the non-negativity constants. So when they satisfy the subjective function but not the non-negativity constants, at that time I will call it as a basic infeasible solution. So there is a basic feasible solution and basic infeasible solution. Now the next point that I want to understand here is the solution degenerate? Now that's the next concept that you want to understand. A degenerate and a non-degenerate solution. A degenerate solution is that solution if you get some of your basic variables as 0. If you get some of your basic variables as 0. Look at this, x3, x4 was your basic variables. Have you got some of them as 0? The answer is yes. Hence this solution is a degenerate. So I'll call it as yes. Degenerate solution, solution is 0. Some basic variable is 0, then it is called as a degenerate solution. Look at the next one. There is no question to be arised over here because it's an unbounded solution. I haven't got any values of the variables x2 and x4. So no point in discussing whether it is a degenerate or non-degenerate solution. So let's put up a dash over here. Let's put up a dash over here because we are not going to discuss about x2 and x4 because we haven't got that values. Let's move ahead. x3 and x2 is some of the values coming 0. The answer is yes. That means the solution is again here degenerate solution. So I'll write yes here. What about this one, the next case? x1 is coming 0 and x4 came 1 by 4. The solution is again degenerate. So I'll again write yes. Again here x3 and x1 are the values, some of the values 0? The answer is no. The values are not coming 0 here. The basic variables did not give us the answer 0. Then this is a non-degenerate solution. Non-degenerate means non-zero values. I've got non-zero values. You can correlate. Non-zero is non-degenerate. 0 is degenerate. So if any of the basic variables, give me the value 0, then it is called as a degenerate solution. And if all my basic variables are non-zero, I will call it as a non-degenerate solution. So that's non-degenerate solution, isn't it? So I'm going to write here no, isn't it? And finally again one of the values is 0, so I'm going to call it as a degenerate solution. So I write yes over here. So students, lot of things are there you want to understand. I started with a solution, then I've taught you what a feasible solution is, then I've taught you what an optimal solution is. So we are yet to get the optimal solution. Then we went ahead and talked about non-basic variables and basic variables. Then we have understood what is a basic feasible and a basic infeasible solution. Then we have moved ahead and understood what is a degenerate and what is a non-degenerate solution. So if any of the basic variable becomes 0, then the solution will be called as a degenerate solution. And if all of the basic variables are non-zero, it is called as non-degenerate solution. Now let's move ahead. Let's go on ahead with the next column of this table. I'm going to get the values of the objective function. Let's get the values of z. So I have x1, x2 as 0. So x1 and x2 are taken as 0. I've got x3 as 0. So x3 also becomes 0. Only x4 is there. So I'm going to get 5 into 1 by 4. So I'm going to get a negative answer. So students, I'm going to write here minus of 5 into 1 by 4. So my answer came minus of 5 by 4. So over here I can say the value came minus 5 by 4, isn't it? So this value is definitely not giving me a optimal solution. So negative value minus 5 by 4 is not allowed, isn't it? You will always get your objective function as a positive value. So this particular value minus 5 by 4, I can say that this is not an optimal solution. So that's minus 5 by 4, not an optimal solution. So I'm going to write one more column here, optimal solution. So that's not an optimal solution. So I'll put up a no here. Let's move ahead. Here again there is no case to be arised, isn't it? Because we don't have any values. Again x1, x4 and x3 are taken as 0. So x1 is 0, then x4 is 0. So x1 is 0, x4 is 0 and x3 is also 0. So minus of 2 x2 and x2 came 1 upon 2. So I'm going to get here minus of 2 into 1 upon 2. The value came minus 1. Again it is not an optimal solution. So I write no over there. Let's move ahead. I have x1 as 0, x4 as 1 by 4, x2 and x4 were taken as 0, isn't it? Next one, okay. Let's come back again. x1 is 0, okay, so this is here, okay, fine. So sorry for the mistake. So x2 and x3 are taken as 0. So x2 and x3 are taken as 0. x1 is also 0, x1 is also 0. So left is minus of x5, x4. x4 came 1 by 4. So here minus of 5 into x4 is 1 by 4. The answer came minus 5 by 4. Again negative answer I have got. That means it is also not an optimal solution. Let's move ahead. Let's take the next set of values. So the next set of values is here, isn't it? So here x2 and x4 are taken as 0. So x2 and x4 are taken as 0. x3 and x1 came 3 and 8. So x1 is 8 and x3 came 3. So that's 2 into 8. That gives me 16 and 4 into 3. That gives me 12. 16 plus 12, I get 28. So see, this is the highest value so far I have got. So I'm going to write yes over here, isn't it? Because that could be the maximum value. You can check the last one also. Obviously x1, x3, x4 are going to be 0. x1, x3 and x4 are going to be 0. And minus of 2 x2. And x2 came 1 by 2. So the final answer was going to be minus 1. So there are plenty of values which are going to come negative. And all of them are not optimal solutions. Only one value came positive, and that was when x1 is 8 and x3 is 3. So my final answer I'm going to write like this. x1 came how much? It came 8. x2 is taken as 0. x3 I've got the value as 3. And x4 is 0. So that is my final solution, isn't it? So that is your optimal solution here, and the optimal value is 28. The optimal value, the maximum value is 28, and it has been obtained for this set of values. That will be called as the optimal solution, isn't it? And this entire table that we have made over here, this can be called as a simplex table for equality constraints. So students, this is how you will solve the question for equality constraints. In our next session, we will see how to solve the particular question if you get an inequality or inequation in the subjective function. So that's going to take a little bit time. So at this moment, you just first of all focus when there is an equality constraint, how to solve a particular question. Again, I'm telling, solve as many questions as you can, because it definitely needs tremendous amount of practice to understand all these things. More important, I have taken all the concepts in the solution itself. So make sure you take your pen, your paper, and you note it down, the concepts that I have taken as the solution was proceeding, isn't it? So that will help you to understand all the basic concepts. Students, I'm going to leave you here. Thank you so much for watching. We will meet in the next lecture. We will be taking simplex method for inequalities. Thank you so much for watching.